Okay, we're going to look at some 2016 practice free response questions that would kind of cover the themes that you would expect to show up on the free responses this year or any year. Okay, so in this first free response, there's a question here about companies selling chili powder and the profit on the sale of X kilograms of chili. So X is going to stand for how many kilograms you have, is modeled by the function P equals 48X plus 140 yada yada yada, where P is in dollars and X is between 0 and 80. So the number of kilograms of chili powder is going to be between 0 and 80. But basically, it's real important to pay attention to the units here. P is just measuring dollars and X is measuring kilograms. So it says find the rate in dollars per kilogram. So that's a perfect, slope issue or derivative at which the company's weekly profit is changing when it sells 32 kilograms of chili powder. So that's pretty straightforward, and it's kind of screaming for you to look at basically what is P prime of 32. And really that's the only thing you're going to have to go and get. So how you want to do that, remember this problem and the next problem are calculator questions. So you definitely want to have the calculator do that for you. Don't even begin to try to do the derivative by hand right now. You can see if you need to do it later. Not that you couldn't, because it's pretty simple power rule stuff. But let's just get the calculator to do the derivative of this thing. So there's two ways you could do it. You could use it, you could do math 8, where you plug in the function and tell it to get the derivative of 32. Or you could do it by graphing the function between 0 and 80 and doing second calc, and that option is 6 there. Get the numeric derivative second calc 6. I think I might go ahead and graph it. Nah, I don't think I'm going to graph it because I don't think we're going to need to do anything else with this thing. So I'm just going to do it using the math 8. Okay, so I ran that through the calculator using math 8 and got an answer of 65.92. I threw a 0 on it so we have 3 decimal places of accuracy. Now, the second part of Part A says, is the company's weekly profit increasing or decreasing? Well, this is a positive number, and I would just say because this is a positive number, is greater than 0, either way, the profit is increasing. So we just need to say because 64.920 is greater than 0, the profit is increasing. Might be good to put P prime of 32 equals in there. I'm going to be kind of quick with my written directions so you're not bored by watching me write all this stuff out. Okay, straightforward. That's an easy 1 or 2 points probably. How many kilograms of chili powder must the company sell in order to maximize its weekly profit? Well, anytime you're asked to maximize or minimize something, you're going to look at the derivative and set it equal to 0 and see where the sign changes. So this just says maximize weekly profit, which is number of kilograms will be 0 to 80. So we do want to now look at P prime, and that we're just going to use the power rule. 48x, the derivative is 48, and then we're going to get 2.8x to the first, and then we're going to multiply 2.8 by negative 0.05, so that's going to be minus 0.14, and x to the 1.8, and then the derivative of negative 270 is 0. So there's your derivative function. In order to find absolute max or absolute min, we want to check the value of the function at the two endpoints. So we need P of 0, we need P of 80, and we need P at whatever value or values the derivative is equal to 0 and changes sign, all the critical numbers. So we can take a quick look at the graph of this thing between 0 and 80. And I looked at that before, and it crosses somewhere around here. And so I'm going to go ahead and graph that and get that intersection for you. Okay, so I set my calculator up. I used a window of negative 100 up to 100. I knew the y-intercept was going to be 48. And I did 0 to 80 on the x-axis, and I get a graph that kind of looks like this, and that x-intercept occurs at 58.358. Now, that is the only critical number that occurs between 0 and 80. And you could make an argument and say, because this function has a derivative that is strictly positive, the p function has a derivative that's strictly positive and then strictly negative, means that the profit function must go up and then come down. So it's going to have just a max. If it's strictly increasing and then strictly decreasing, it must look like that. So this point right here is going to turn out to be our absolute max. So you could either write that all out and say because p is strictly increasing and then strictly decreasing, x equals 58.358 represents an absolute max. I think it might be just easier to just get the y value at the endpoints and at the critical number, and then just show which one's the largest and say there's your absolute max. Probably safer that way because you don't have to write out a sentence. Okay, so I found the value of the original function at the endpoints at 0 and at 80, got these two numbers, negative 270 and 1873.32, and then at the one critical number I got 2,893. So you would just need to indicate that the max occurs at x equals 58.358 kilograms of chili powder. And there you go. And the justification is by checking the endpoints and the critical number. That's all you need to do there. Okay, for part C here, they're going to start getting rid of their chili powder. They're going to sell it, and they've got a function that says at t hours after the store opens, they're going to sell at a rate modeled by S, given by 2 plus cosine pi over 10 t squared. So it's really important to recognize that this is a rate function, kilograms per hour. And so they say estimate the amount of chili powder in kilograms that will be sold during the first 5 hours. So if you have a rate of kilograms per hour and you want to know how many kilograms, you're just going to integrate from 0 to 5. That should be jumping off the paper at you. So we just need to write that we're going to integrate 2 plus cosine pi over 10 t squared dt from 0 to 5. And you can decide if you want to do that using the Math 9 option, where you get a numerical integration just to get the number, or whether you want to graph it and do the area under the curve using second calc integrate. The only way I would decide is take a look at part D, and now they want to know S prime. So if we have this in y equals, we could easily find the numeric derivative at 3 by having the graph showing up and then just hitting second calc. I think it's 6. Second calc 6 gets you a numeric derivative. And we can use second calc 7 to get this function. So if we're going to set this guy up for our window, you'd want to have your x's, x min at like 0, and let's get rid of that, x min at 0, and x max at least at 5. I went ahead and went 10. And then y min, it's a cosine function. It's going to go up and down 1, but it's going to start at 2. So it's going to go as high as 3 and as low as 1. So I would do like 0 and then y max at 4. And make sure you're in radians. So doing that integral, we'll see what we get. The lower limit is 0, the upper limit is 5. And doing that integral, we get 11.433, 0.43288, but rounding it up to 0.433. And it just says estimate the amount of chili powder. So that would be kilograms, but it doesn't ask for the unit, so I don't think it would be wrong if you didn't include them there. Now, for part D, find the value of S prime of 3. Well, S prime of 3 is the derivative of this thing. So because I already had it in y equals, I can now just use second calc 6 and get that number. Second calc 6 with the x value of 3, and the calculator spits out negative 0.582 2. Now, S was measuring kilograms per hour, but the derivative would measure that rate of change in time, so it would be kilograms per hour squared. So if we wanted to come up with a sentence for that, we want to start by saying the rate, because a derivative is always a rate. And before we had the sale of chili powder in kilograms per hour. So we'd say the rate of change in the rate that chili powder is being sold in kilograms. We should probably put the number there. So we can say the rate of change in the rate of sale of chili powder is decreasing because it's negative at 0.582 kilograms per hour squared, or kilograms per hour at the time time t equals 3. You always want to include this number that you're taking the derivative of in the context of your problem when they say explain the meaning of it. It would be the same thing here if we were given this integral back in part C. If you were given that integral and you needed to explain what it meant, it would be the total amount of chili powder sold during the 5 hours from t equals 0 to t equals 5. You always want to include those limits in your explanation. So there you go, kind of an awkward structure of a sentence there. The rate of change in the rate of sale of chili powder, and it's decreasing at 0.582 kilograms per hour squared at time t equals 3. You have those two rates in there. But you're going to need that because it's essentially the rate of a rate. All right, that does it for number 1. Hopefully we can pull 9 out of 9 on that.